Hello, good people, and welcome to this physics video. Today we are talking about vectors, scalars, and vector addition. Now, normally when I start this lesson in class, I like to take this 10-pound weight, which I have tied to a string here. Wait, let me show you. Actually, let me make this big. What are we doing here? There we go. Okay, I like to take this 10-pound weight, which I have tied to a string. And I tell one of the young men in my classroom who thinks himself very strong, hey, I'll give you $1 if you can hold up this weight without any angle here in the two strings. And one of the students will come up and he'll take the two strings and he'll pull to the side as hard as he can. But no matter what, you always have an angle in the strings. They're always slightly angled downward. You can never get them to be a perfect horizontal line with the weight in the middle. Now this weight is only 10 pounds, so why is it not possible? Well, because the weight is pulling down. And you can't cancel out a downward pull with two sideways pulls. No matter what, when you pull on the strings on the side, you have to have a part of your pull on the sides that is up in order to cancel out the down. Two horizontals won't cancel out a down. And this is how I introduce the concept of vectors. That in physics, it matters not just how much something is, but also in which direction it goes. You can be as strong as you want, and no matter how strong you are, there's no way that you can hold those two ropes without any little bit of angle in the ropes. Because it's not just the size of your force that matters, it's also the direction. Today, we are going to be talking about vectors, scalars, and vector addition. Okay. And, why am I not charging? Hello. Okay, we're good. Sorry, everyone. Today we're talking about vectors, scalars, and vector addition. And now, most students don't know about vectors from their physics class, but they do know about vectors because they've seen Despicable Me. And they know that vectors have both magnitude and direction. Oh yeah. So here's what we have is we have two types of measurements in physics. One type of measurement, let's change our color here because colors are fun. Yeah, let's go. I mean, this is kind of bold. Can you even see that? I don't even know. We'll go red. There are two types of measurements in physics. We can measure quantities that are what we call, wait for it. Hello. It's just gonna take a really long time to load. Sorry, everyone. We're taking our time. Yeah, taking our time. Okay. Yes, okay. So there are two types of measurements that we can make in physics. One type of measurement is a scalar measurement. And another type of measurement is a vector measurement. A scalar measurement is a measurement that has a size and no direction. A vector measurement is a measurement that has size and direction. An example of a scalar measurement would be something like time. Now, well, that was a terrible M. Let's try again. Something like time. Now, time, we know, can go forward, and so in that sense it has a direction, but you can't have time to the left, you can't have time to the right, you can't have time to the north or time to the south. And so in that way, time is a scalar quantity. You can have a certain amount of it, but you can't have time in any direction. Likewise, mass is a scalar quantity. Mass has an amount, but it can't have any direction. You can't have 5 kilograms of mass to the north or 5 kilograms of mass to the left. It's never a directional kind of thing. Meanwhile, there are other things that are vector kind of things where it has both a magnitude and it has a direction. For example, force is a vector. Force is a vector because it has a size, it has a magnitude, like you could push on something with a force of 10 newtons or you could push on something with a force of 100 newtons, but it also has a direction. I could push something down, I could push something up, I could push it to the left or to the right or to the north or to the south. So force has a direction and so it is a vector. other things that are scalars and vectors that get really interesting here. One thing is we make a distinction between two different values. One we say is a scalar and one we call as a vector. And these two values are distance and displacement. Pretend that says displacement. But wow, it really is kind of squiggly in there. Distance and displacement. Both distance and displacement are very similar ways of talking. It's just that in one, we don't account for distance we don't account for direction, and in the other, we do. For example, if I wanted to say that I drove 4 miles away from my house, that would be a distance. Then I said away from my house, which makes it kind of... If I said I drove 4 miles, that would be a distance. If I said I drove 4 miles north, then we call that a displacement because I included direction. So, very similar concepts, but one of them we talk about direction, and one of them we don't talk about direction. The other weird thing about distance and displacement, and we'll come back to this, is that sometimes distance and displacement aren't even the same number. Whoa, sorry. I'm kind of dying for no reason. Distance is actually how far you go. It's literally how far your feet carry you. So, for example, if I started here and I walked 4 miles to the east, and then from there I turned back around and I walked 3 miles to the west. If I asked you my distance, you wouldn't care about my direction at all. And you would say, well, you went 4 miles, 3 miles, your distance was a total of 7. But if I asked for my displacement, you would care about direction. So you would say you went 4 miles east and then 3 miles west. So your total displacement, in terms of how far you went, accounting for direction, is you went a total of 1 mile east. And that would be your displacement. So your distance that you actually traveled would be 7 miles, but your displacement would be only 1 mile east. We talk about distance and displacement differently because when we account for direction, we treat direction a lot like positives and negatives. You know how when you were in elementary school, you had something like a number line like this, and you said, hey, what if I started at 0? And you said, what if I went 1, 2, 3 spaces into the negatives and made it to -3? And then you said, and what if then from there I went back into the positives and I went from -3, 1, 2, 3, 4 spaces into the positives. You would say I ended at +1. This is how we do vector addition when it comes to displacement. We call some directions the positive directions and other directions the negative direction. In this case, when you add together with directions, then you end up with some positive and some negative, and they might cancel each other out. This is not the case with distance, where with distance, I just want to know how many hops that I made. So if I started at 0 and I hopped 1, 2, 3, and then 1, 2, 3, 4, you would say that I went 7 total hops. So distance and displacement accounts for direction, and distance does not account for direction. It's just how far your feet travel. Could you please tell your neighbor except that you don't have a neighbor with you probably, please tell yourself, if you, let's say you drove 6 miles to get to school, what is your total distance traveled from the day if you went from your home to school and then back to your home? And what's your total displacement for the day if you go from your home to school and back to your home? Did you say that your total distance if you travel 6 miles to school and 6 miles back home, your total distance that you travel is 12? But your total displacement was 6 miles in one direction, 6 miles backwards, so you end with 0. In fact, your total displacement to and from your bed each day is 0, but that doesn't mean that you don't cover any distance. That is the difference between distance and displacement. There are other scalars and vectors, which we also pay attention to, namely, the two important ones for today are speed and velocity. We will talk way more about speed and velocity about 2 videos from now, but for today, the difference between speed and velocity is that speed is how fast you're going, velocity is how fast you're going and which direction you're going. So if I said that I was going 40 miles an hour, you would say, cool, and that would be my speed. If I said I was going 40 miles an hour north on Kipling, then that would be my velocity. So speed does not account for direction, velocity does account for direction. When we calculate speed, the way that we calculate speed is we do distance over time. When we calculate velocity, we do displacement over time. This means that velocity also has positive and negative values. For example, if you went on a run or on a walk and you walked 4 miles to the east and then 3 miles back to the west, the whole time that you were traveling this way to the east, let's say that we call east the positive direction, the whole time that you're traveling this way to the east, your velocity is positive because we say that you're moving forward. But then the whole time that you're going back this way, your velocity is negative because you're moving backwards or going back in the opposite direction. Now, here's something that some students think, oh, so if I'm going this way and this way is forwards, and then I start moving backwards, that's negative. But if I just turn around, now this way is positive. That's not the way that we define positive and negative. We don't define positive and negative based on which way you are facing. We define positive and negative based on direction. So we would say this direction is always positive and this direction is always negative regardless of which way you're facing. So we have scalar values like time, mass, distance, and speed. These guys don't account for direction. Then we have vector values like force, displacement, and velocity. These guys do account for direction. Oh gosh. See, I keep saying this thing about my battery. I might pause really quick and fix my battery. But in the meantime, this is a difference between scalars and vectors. There are plenty of other things that we could put on this list, but that's a pretty good list for now. What we're going to do next is we are going to learn all about how to add vectors together. You've already kind of seen this here where we have to take care of our positives and negatives, but what we're going to do next is see what happens if you go something like 4 miles to the north and then 3 miles to the east. How do you add those together? Let me pause this, get my battery situation figured out, and then we'll come back and discuss adding vectors together. One moment, please.